Hello and welcome. Now we have a question involving solving for an unknown n, which is in the power of our polynomial function. It is given that the coefficient of x cubed in this particular function is the same as the coefficient of x squared in another function. Here we are required to find the value of unknown n. Here, since the power of n is unknown, we cannot expand the polynomial function completely. However, in this case, we are only interested to know the coefficient of x cubed and the coefficient of x squared in these functions. We can make use of the formula from binomial expansion, where the formula of binomial expansion is given as follows. Therefore, we can now write the x cubed term in 1 plus 3x to the power of n is equivalent to nc3 multiplied by 1 to the power of n minus 3 multiplied by 3x to the power of 3, which will simplify into nc3 multiplied by 27x cubed. Now we repeat the same thing for the x squared term, which will give us nc2 1 to the power of n minus 2 nx to the power of 2. Now in both cases, you can see that our 1, since the 1 to the power of anything will still be 1, which will easily allow us to eliminate the term with an unknown power. Hence, this will give us nc2 multiplied by n squared x squared. Since we know the coefficient of x cubed and the coefficient of x squared in these two functions are the same, therefore we equate them together, and that gives us nc3 multiplied by 27 will give us nc2 multiplied by n squared. In this case, I ignore the x cubed and x squared since we are only interested to find the coefficients. In this case, in order to solve for the value of n, we need to make use of the formula where NCR is equals to n factorial divided by n minus r factorial divided by r factorial. Applying the formula in this case, that will give us nc3 is n factorial divided by n minus 3 factorial divided by 3 factorial multiplied by 27 will give us nc2. nc2 is n factorial divided by n minus 2 factorial multiplied by 2 factorial. And this again multiplied by n squared. First of all, we can see that we can easily cancel the n factorial since they have a common terms on both sides of the equations. Now let us move the unknown n factorial to the left side so that we will get n minus 2 factorial divided by n minus 3 factorial. And now we are going to move all of the constants to the right side along with the n squared. And that gives us n squared multiplied by 3 factorial divided by 27 and 2 factorial, which will simplify to become 1 over 9 n squared. Here comes the interesting part. How do we simplify these two terms involving the factorials? Let us recall the definition of n factorials in general is the same as n multiplied by n minus 1 multiplied by n minus 2, and we keep multiplying until we get 1. This is a definition of n factorial. But let's not forget that if I were to ignore the first term, n minus 1 multiplied by n minus 2 multiplied by all the way to 1 is essentially n minus 1 factorial, which means that we can simplify our n factorial into n multiplied by n minus 1 factorial. And by the same patterns, we can also rewrite our n factorial as n multiplied by n minus 1 multiplied by n minus 2 factorials, and so on and so forth. With these properties, we can rewrite our n minus 2 factorial as n minus 2 multiplied by n minus 3 factorial divided by n minus 3 factorial, and that will give us 1 over 9n squared. And now we can easily cancel the term n minus 3 factorials. Continue to simplify everything. We will get n minus 2 equals to 1 over 9n squared, or rearranging everything will give us n squared minus 9n plus 18 equals to 0. We can easily factorize this, which will give us n minus 6 and n minus 3, which means that our final value of n is therefore either 3 or 6. And that is it.